And this morning, I ran the numbers again. You're the first person I'm telling. The object will make its closest approach to Jupiter on March 16th, 2026, and it will actually reach our system in November 2025. Astronomers have now captured images of 3I Atlas, our third confirmed interstellar visitor, and something about it refuses to add up. We're seeing a jet of material pointing directly at the sun, stretching more than 1 million kilometers into space. Out here, the solar wind races at nearly 400 kilometers per second. Natural cometary gas drifts outward at maybe 400 meters per second. Yet this object is pushing material forward, straight into a wind 1,000 times stronger than anything it should survive. It's like watching someone walk calmly into a hurricane and never lose balance. And it has been doing this for weeks. Here's the problem. The math that tries to explain this as a natural comet demands that the object be losing more mass than it actually contains. Peer-reviewed papers attempting to address this have already been written, and every major journal has refused to publish them. Not because the calculations are wrong, but because the conclusion makes people deeply uncomfortable. If you want the truth, subscribe, because what we're seeing now is the data NASA isn't emphasizing. The sharpest, most recent images of 3I Atlas aren't coming from space telescopes. They're coming from backyard astronomers. And the patterns appearing in those images don't match any of the official explanations. So let's talk about what's really happening. 3I Atlas entered our solar system this summer on a hyperbolic interstellar trajectory. It didn't originate here. It passed perihelion on October 29th and is now on its way out. Once it leaves, we'll never see it again. At the moment, it sits roughly 300 million kilometers from Earth, about twice the Earth-Sun distance. And in 18 days, it will make its closest approach to us since Hubble captured that now iconic image back in July. But here's the contradiction. When comets move away from the sun, they fade. Less heat means less sublimation. The coma contracts, the tail weakens, activity drops. 3I Atlas should be dimming into silence. Instead, amateur telescopes are still capturing razor-sharp structures, active jets, and brightness fluctuations that shouldn't be possible at this stage. And all of it leads back to one anomaly, the one that started this entire debate. Look at the images. You'll see two tails. One pointing away from the sun, perfectly normal. Solar wind and radiation pressure always push dust and gas backward. But the other tail, the one pointing toward the sun, is the anti-tail. And this time, it isn't an optical illusion. Usually when Earth crosses a comet's orbital plane, we can see old dust projected ahead of the nucleus, creating the illusion of a forward-facing tail. That's just geometry, a line of sight trick. But Earth never crosses the orbital plane of 3I Atlas. The viewing angle cannot produce this effect. The anti-tail is real, and it's 1 million kilometers long. Now here's where physics raises a red flag. Solar wind at this distance moves at 400 kilometers per second. Comet outgassing moves at roughly 400 meters per second. To push material forward against that kind of wind, the ejector would need to be moving 1,000 times faster than natural comet gas can achieve. Picture trying to walk 10 kilometers per hour into a 10,000 kilometer per hour storm. You don't walk, you get atomized. This is why comet tails point away from the sun. And on the rare occasions when outgassing is strong enough to momentarily create a forward jet, it survives for a few hundred kilometers, maybe a couple thousand at most. Never 1 million. The key here is ram pressure, the force exerted by fast-moving particles slamming into slower ones. Ram pressure scales with the square of velocity. So for this anti-tail to remain intact under that assault, the material must be at least 1 million times denser than the solar wind itself. If that's true, 3I Atlas is shedding roughly 200 metric tons of material every second just to maintain that structure. And that calculation only covers a narrow region of the tail. The real number could be far higher. Over October and November, the object would have lost several billion tons, about 10% of its minimum estimated mass of 33 billion tons based on the earliest measurements. And here's where everything breaks. NASA has stated the nucleus may be smaller than that estimate. Fine, but if it is smaller, then losing 10% of its mass should have fractured it or completely destroyed it. Yet the object remains intact. Now let's talk about trajectory. Comets ordinarily display non-gravitational acceleration, small nudges in their orbit caused by irregular outgassing. They behave like slowly leaking rockets. But all summer, 3I Atlas showed none of this. It moved like a solid, inert rock, stable, predictable, purely gravitational. Then it passed behind the sun on October 29th. The moment we lost visual contact, sensors picked up something new, a measurable change in its motion.
Acceleration. For a natural comet to show the level of thrust observed, it would need to eject more than 10% of its total mass as high-speed gas and dust. But we already accounted for that first 10% just to explain the antitail. The numbers still don't balance. If 3I Atlas is truly a natural comet, then over 2 months it should have lost 20% or more of its total mass. That much loss should destroy a small icy body. It should break apart, fragments, or collapse. The only alternative would be that the comet is far larger than the observations indicate. But that contradicts its brightness, thermal signatures, and reflectivity. So a third possibility remains: propulsion, chemical or ion. Rocket exhaust moves at about 4.5 kilometers per second. Ion thrusters operate even faster. That's 10 to 10,000 times more efficient than thermal outgassing. Plug those numbers into the equations, and suddenly everything fits. The mass budget works, the acceleration makes sense, the structure stays intact. The math aligns. This is the conclusion several researchers have submitted to major journals. Not speculation, but calculations and physics. Yet every journal rejected the papers before peer review even began. There's more. The antitail is not chaotic. It's sharply collimated, straight, organized, unnervingly clean. It has remained stable for days. But 3I Atlas rotates once every 16 hours. If multiple vents on the surface were producing jets, rotation would cause them to fan out. You would see spirals, cones, flickering trails as different regions rotated into sunlight. We don't see that. Instead, we see a single, perfectly uninterrupted column, as though the source either isn't rotating or is actively compensating for rotation. The only natural explanation would be a single vent firing only when it faces the sun. But if that were the case, the jet would pulse with every rotation, a rhythmic on-off cycle, a heartbeat. There is no pulse. The jet is constant. Then comes another anomaly. 3I Atlas brightens and dims by 10 to 20% as it rotates. NASA states that most of the observed light comes from the coma, the cloud of gas and dust surrounding the nucleus. But the coma doesn't rotate with the nucleus. A comet's gravity is far too weak to force the coma to spin with it. The brightness should remain roughly uniform. Yet amateur astronomers detect brightness shifts perfectly synchronized with the comet's rotation. That should be impossible under natural physics. The coma is behaving like a structured, controlled envelope rather than a drifting cloud. And now we arrive at the strangest part. 3I Atlas is heading toward Jupiter. Not to collide, but for a precise flyby. And the path is not random. It's lined up with Jupiter's Hill radius, the region where Jupiter's gravity dominates over the Sun's. This zone is extremely useful if you want to place something into long-term orbital stability. Space agencies use similar gravitational parking lots all the time. Lagrange points, stable pockets where probes can sit for years without drifting. Initial calculations predicted that 3I Atlas would pass inside Jupiter's Hill radius in March 2026. The alignment was remarkably close, within 1 standard deviation. Avi Loeb, the Harvard astrophysicist tracking the object, sent a formal report to NASA's Jet Propulsion Laboratory highlighting this odd precision. JPL did not respond, but within days they quietly updated the trajectory model. the non-gravitational acceleration was revised, first by a factor of 4, then by a factor of 6. The new model places 3I Atlas just outside the Hill radius. Convenient. How does an institution like JPL miscalculate that dramatically? And why did the correction happen immediately after Loeb's analysis? As Loeb put it, the Vatican insisting Earth was the center of the universe did not change the Earth's orbit around the Sun. Adjusting a model doesn't change the object's actual path. We'll know the real trajectory in March. Spacecraft near Jupiter, Juno, JUICE, Psyche will track the flyby. Amateur astronomers will track it too. The data will show exactly where 3I Atlas goes. If it crosses into the Hill radius, despite NASA's revised model, serious questions will follow. Here's what we can say with certainty. 3I Atlas has a 1,000,000-kilometer antitail that defies standard solar wind physics. Its mass loss rate should have destroyed it by now. It showed zero non-gravitational acceleration for months, then accelerated only when it passed behind the Sun, when no one could see it. Its jets ignore rotational dynamics. Its brightness variations contradict how comet comas behave. And its trajectory is aligned with a gravitationally significant zone near Jupiter with suspicious precision. None of this proves artificial origin, but the natural explanations require physics we have never observed. Mass loss rates that don't match known chemistry, structural durability that contradicts comet behavior, trajectory coincidences bordering on impossible. Meanwhile, artificial explanations, thrusters, stabilization systems, controlled navigation fit the data without bending physics. Yet every paper making this argument cannot even enter peer review. In 18 days, 3I Atlas makes its closest pass to Earth. Hubble, James Webb, and major observatories will all be watching. We'll get sharper imagery, richer spectra, better insights. Since it's now moving away from the Sun, natural behavior predicts fading, cooling, quieting. A dim, stable nucleus. But if current patterns continue, we won't see quiet. We'll see sustained activity, stable jets, anomalies that refuse to resolve into ordinary comet physics. And then comes March 2026, the Jupiter flyby. That is the real test. If 3I Atlas enters the Hill radius, despite NASA's updated numbers, the coincidence becomes nearly impossible to dismiss. This isn't about aliens or conspiracies, it's about math. Either the physics works or it doesn't. Right now, natural explanations require extraordinary exceptions. Artificial explanations require ordinary engineering. Extraordinary claims demand extraordinary evidence. But no one is making extraordinary claims. We are simply asking why the standard explanations fail again and again. The data will decide. Not models, not revisions, not assumptions. Real observations from independent sources. We are watching new physics unfold in real time. Whether that physics is natural or engineered, we're about to find out. Mark March 16th, 2026. That's when the numbers stop being predictions. That's when we learn the true path of 3I Atlas. And that's when we discover whether NASA's revisions reflect reality or whether they were designed to make an uncomfortable coincidence disappear.